All right, guys. Hey, we're going to do properties of logs. If you have questions, let me know, but this is going to be video recorded for you, and then I'll post it for you so you have it for later on. Anything that you don't want to write down necessarily, again, you can refer to this video, or you can take a picture during class. There are some properties of logarithms that are new to you, and I'm going to show you kind of how to solve, but this is basically all the properties that you need. The first one I crossed off, and then I circled the bottom. The mainly reason that I did that is because they're basically the same thing. I like the bottom formula a little bit better. With logarithms, when you're adding logarithms, okay, you can actually multiply those together, or if you're subtracting, it's division. Yeah.
I forgot my glasses, so I can't see anything.
No problem.
So whenever we do all these, are there different notes we come up with a bunch of different formulas for everything? Are we gonna have a list of formulas? No, we just have to memorize.
You said you were gonna put them in the test.
So the only formulas that you would probably not need is if you had like the Richter scale. The question was, do you need to know all these different types of formulas and ins and outs for the exam? The things that you will need to memorize are what we're going over today. You'll also need to know the exponential y is equal to a times b to the x, and you'll have to know the compound interest formula. Okay, it's the same thing that's expected of the Algebra 2 class, the just general Algebra 2 class. So you guys will definitely need to know those. But if there's something like, I think we did something with Richter scale and seismonic activity, I will give you the formula for sure. The product property and the quotient property and the power property and even the exponential log inverse properties, once you start working with them, for the most part, they kind of become second nature because they are a little bit more simplistic. Multiplication means addition. Division means subtraction. And then anytime that you have an exponent, you can actually pull it out front. Now, there's two different ways. There's an expanding of your logarithm, and then there's a contracting of your logarithm or simplifying. I'm going to show you, I believe, how to do one of those ways, and then you'll have some practice on it. There's also the exponential logarithm inverse property. It basically, if your base and then your number are the same, if you have an exponent, that's your answer. Or if you have a base to an exponent that is a logarithm that has the same base, then whatever's out front of that logarithm is going to be your answer. The reason that happens is because of that whole switch that you also have to know about how to switch from an exponential to a logarithm. It gives you that answer. And I had a student earlier today kind of explaining it that made sense is if I took, for instance, this log base and I made this b to the x would be equal to b to the x. Okay. And that's kind of how you would have to take a look at those. I'll give you another minute or two if you're copying it down, and then we're going to go into a couple practice problems for you. It should wrap up here in about like 10-ish minutes. I have not yet looked at it. Yeah, I'm sorry. Yeah, the question was, will there be graphs on the exam? I have not yet looked at the exam, so I don't know, but I will be able to tell you guys that. Okay. All right. Does anyone need more time? Okay. Yeah. It's an inverse of logarithm is its own thing. It's essentially the inverse of an exponential.
But it's like it's something like sine, right? Like it's not like a number you replace.
You can use your calculator in order to derive it, and you'll be able to use your calculator on a part of the exam that you need it for. But there's two different types of log. There's common log, which has a base of 10, which is like what your calculator will do, and then there's ln, looks like in on your calculator. It's called natural log, which has a base of e. If you watch those videos, you'll be. Yep. All right, so here's example 1. Given log base 2 of 5 is approximately 2.3219, approximate the value of log base 2 of 5 over 2. This looks like it could be a little bit confusing, so I'm going to make it super easier for you. One of the first things that you notice here is that we have division. And if you look at those rules that we just followed, division means that you split into two things that are subtracted. So this actually becomes log base 2 of 5 minus log base 2 of 2. Now, log base 2 of 5, they were kind enough to give us. They said it was 2.3219, which kind of helps because, like I said, most of this is your non-calculator type of things that you'll see. And then you also had that formula that said that you have log base b to the x is equal to that exponent. So these both have the same number. The base is 2, and then the number in front of the log is 2. Since there's nothing there, this is technically 2 to the first power. So this becomes minus 1, giving your answer as 1.3219. Yep.
Can you explain the property of log base b to the x and how it equals x?
Yeah. So the reason that this happens is because if I were to do, remember the whole like b to the x is equal to y, and you switch it to log b to the y is equal to x. If I do that, this is b to the x equals b to the x. This b to the x is what you see here.
Okay.
Circle. It's the whole entire thing.
Okay. And essentially, like what it's saying is like if both of your subtractions have the same base, then it's equal to the x.
Equals to the exponent. Yes. All right. Moving to, yep. Say that again. It'll always equal whatever your exponent is, as long as your base and your number are both the same. So, for instance, here's another example. If I had log of 5 to the 5, 3, my answer is 3. Because these will cancel, and I'll just be left with whatever that exponent is. Think of it as two, like if you have, just kind of throwing this out here because I think this is interesting. Say I have it equal to x. If I do my change, I now have 5 to the x is equal to 5 to the third, and then x is equal to 3, which we just established with this. I'm sorry, I'm circling a lot of stuff there, but it just kind of all reverts into that one big circle. Okay. All right. Example number 2, write as a single logarithm. So I'm going to take you through the steps on how to actually, so last one we kind of expanded. This one we're going to contract everything down into one log. When we write as one single logarithm, we will literally write log one time, and that's it. So give you a second to copy this down. Subtraction, following PEMDAS, there's no parentheses, so we'll do from left to right. Subtraction means division. So this is going to break down into log base z of 2a over b. I'm going to do this in two parts. Some of you might be able to do it in one later. This then means multiplication. So it'll be log base z of 2a over b times bc. Now don't be fooled. This is bc in the numerator. It's over 1. So now if you notice, I've got a b on the bottom and a b on top. Those will cancel out. And my final simplification will be log base z of 2ac. Yep. Where did I get the log? You're going to have to speak up because I can't hear you. The properties that we stated at the very beginning here, the quotient property, where if we have subtraction, it automatically becomes division, or if we have addition, it automatically becomes multiplication. We use those two properties in here, so this subtraction automatically becomes division, and then the addition part automatically becomes the multiplication. So we can form it into that one logarithm. Yeah, good question. I think we only have 6. Yeah, some of them are going to go pretty fast though. Yes. Yeah. So one more time. 2a, log 2a minus log b. That's subtraction, so it becomes one log that has division. And then we take that log and we add it to another one, and addition means multiplication. So it's all under one log now as multiplied. I have a b on top and the b on bottom, so they cancel, and I have 2ac. I'll get that in a second. All right. Yes. If you started with 2a over b, you could expand it to subtraction of 2a minus b. Yes. You would do the opposite. So like the question was, if I'm correct, if you started with this, that would technically look like this. Yeah. You're just trying to get it simplified. Yeah. You wouldn't want to expand it again. Okay. Yes. Yes, we're replacing addition and subtraction with the multiplication and division in order to just keep it under the one lock. So technically, if I wanted to, I could expand this one to be a final of log z2 plus log za minus log zb if I wanted to expand it. But since I don't, I want to shorten it, then I'm just going to make it so it's all the multiplication and the division parts. All right, we're going to move on to example B. Okay. I know that a lot of you have had questions on this, so I'm going to kind of walk you through this one too. Because it brings in that exponential element where if you have a number out front, it can automatically become an exponent. So I'm looking mainly, right now I'm looking mainly at this here, okay? One of the properties states that if I had a I don't know, log b, then it's also the same as saying log b to the a exponent. So in this case, this is going to become log base b to the x cubed. And then because I have parentheses, I have to do this addition, multiplication first. So this is going to become log b to the 4x. Last now, I have subtraction. Remember, subtraction means division. So I'm going to write this all as one log. X cubed is on top because it comes first. And then 4x goes on our bottom. X cubed and x can simplify. And that's the whole point of combining these logs, is to make sure that we simplify our problem. And that'll be our final solution. Okay. So addition means multiplication. Subtraction means division. And if you have any number in front, it can be changed into an exponent. Or vice versa. If you have an exponent, it can be moved out front. Yeah.
Why is 4x the denominator?
Because it's why is 4x the denominator? It's the second term. So whatever you're subtracting by goes in your denominator. Yeah. You can't, if they don't have the same base, like where you see the b's, you can't combine them. Yeah. All right. Example number 3. We're going to move away from the expanding and contracting, and we're going to use those inverse rules a little bit just to kind of show you. Like, I can look at this right now without doing anything, and I can tell you my answer is 24.
It's 3 minus 7.
No.
That'd be 27 minus 3.
Here's how we're doing it. Okay. First off, we know that we're going to use this rule. Right? I've been referring to that same rule since we kind of started here. 27. If I notice that I've got a 3 here, 27 is a multiple of 3. 27 is what exponentially? 3 to the third. 3 to the third times 8. Our base and our number are the same, so our exponent is the answer.
When do you know the split like 27?
You don't necessarily. So say, for instance, you didn't know. Okay. Here's a way around it. It might be a longer way around it, but it's still kind of a way around it. Set it equal to x. 3 to the x power equals 27 over 8. Now you need the same base. It goes back to those laws of exponents. 3 to the x. This is 3 cubed. X is equal to 24. Okay, so if you don't know how to do it, you can still use that workaround from that same base, from those laws of exponents that we did before. Yes?
Okay, so what if 27 wasn't a multiple?
If it wasn't a multiple of 3, you wouldn't be able to do it this way. You'd have to do the second version that I showed, where you set it equal to x and then solve it out. You could still simplify it as long as your number wasn't something super crazy. In that case, then you'd probably have a calculator for it, and you'd be able to just plug it into your calculator. Yeah.
Well, what does log actually represent? Or is it just kind of made up?
A log is kind of like a made-up word to say it's an inverse of an exponential. So it's kind of like a subscript almost to say like this is what we use for our exponentials, the inverse of an exponential. Yeah. Jake?
Is that 3 from the 3 times x? Is that 3 from the base of the log, or is that the cube of 27?
The cube of 27. Yes, the 27, the 3 cube. Yeah, I couldn't speak. All right. Example 4. We're over halfway. We're good. How good have you gotten? Anybody look at this and tell me what the answer is?
It's 5 plus. No.
So the first part is 5. 13. Good. So one of the other laws that was mentioned at the very beginning that we haven't talked about. If these two numbers are the same, then this is your answer. We've talked about the first part. So here we talked about this. But if we can also say here that if they have the same base, that if we have a number to an exponential log and the log is the same base as the previous number, whatever's out front of that log is going to be your answer. They're not the same base. The one is a log and the other one is an exponential. It's only whenever they have the same base that we can do the addition, subtraction into the multiplication and division. Okay. The 3 and the 3 are the same. The 8 and the 8 are the same. No. So I think what Murphy was kind of talking about is why didn't we do something like this and make it look like this? It's because this is an exponent. This is a log, and they're not the same. If their bases are the same, we can do that, but if they are different, then we can't. All right, moving to example number 5. The 2 out front, what happens to it? Thank you for raising your hand, Evie. Becomes the exponent. So this is going to be log 12 6 squared plus log 12 of 4. Right? They have the same base of 12. We're adding. That means what? The multiplication. So log of 12, 36 times 4. 6 squared, 36. 144. Thank you. Okay. So then it goes back to, again, how do you want to solve? You can do this 2 ways. You can do it I know 144 is 12 squared. So this makes log base 12, 12 squared. And my answer is 2. Done. Or we can set it equal to x and say 12 to the x is equal to 144. And we also get 2.
So, I'm going to the one before this.
You could technically bring those out front. Yeah, you could do that. Yep. Right. Questions at all? One last thing. Change of base formula. Listen, do not write this down. Please do not write this down. Just look up here and see what I'm about to show you. All of this is literally just telling you this. It's just showing you the steps on why it happens. Essentially, here's all you need to know. If you have a number, I'm going to put numbers in. Obviously, you can't plug this into your calculator. Okay, because your calculator only does base 10. Certain calculators you can, but it's like the TI-84 Plus or whatever it is. They have the special button. All this is saying is that you can make this the log of 5 divided by the log of 3 and then solve it. That's it. Okay, it's called change of base. That's all you need to know. And I think I've hinted to it before in this class as well. But all of this is just showing you the work that becomes this. So it happens with log and it happens with ln. But essentially, if your base is not 10, okay, then you can use this to plug into your calculator. It's a shortcut way. So on the calculator section, when you see something and you're like, oh my gosh, I can't do it. Because look, if you did this, just showing you this one because it is kind of a nice one. The log base 3 of 5, if you set this equal to x, 3 to the x is equal to 5. I don't know that. I don't expect you to know it. So we can use the change of base in order to plug it in our calculator and solve. I just want you to practice that one skill. If you have a calculator, great. If you don't right now, that's okay. But right here, evaluate log base 7 of 14. Plug it in your calculator using change of base. And tell me 4 decimals. Hopefully you plugged in log of 14 over log of 7 in your calculator. Anyone tell me what they got? McGuire?
1.356.
1.356. That'll work. Carter?
So that would just be the number on front. B would be the log part.
Yes. And it changes it so like your logs automatically have a base of 10. Then. I'm going to go ahead and I'm going to stop sharing. Hope you enjoy the video.